Hi everyone. Thank you for clicking on the link to our presentation here. As I'm sure you're aware, we didn't get a chance to present live during the session, so we really do appreciate you taking the time to watch. As far as introductions go, my name is Matthew Dickey. I'm the training manager at Software Technical Systems. Software Technical Systems is a software company that creates the road design software called RoadEng. So RoadEng has been around for 30 plus years, and it was created specifically to help forest companies on Canada's west coast design their roads to access their timberlands. Since that time, our software has grown, improved, and we've branched out to work in other markets. We've been picked up by folks in the civil sector, mining, energy, agriculture, etc., and we're used all over the world. Since growing and expanding, we've never lost sight of our roots, and we've always made sure we've maintained a large presence in the forest sector. Other things that were important to the developers from the company's start was to make sure that the software always stays easy to use and operates efficiently. So it's fairly light if you're dealing with large data sets, and we pride ourselves on just how easy it is to use. So usually planners can pick it up and teach themselves how to use it very quickly. So more about road design in general, and I think that's what we'll focus on for most of this presentation, is how designing your roads can improve your operations. So I've done a little bit of just review of the topography in Belarus. It looks like it's typically dominated by flat terrain, or relatively flat terrain, and a lot of the forest resources appear to be have roads nearby, but they certainly could benefit by having more roads to improve operations efficiency, reduce skid distance, etc. Typically, it seems a lot of folks in flatter areas might have a bit more resistance than those in mountainous terrain to see the value in designing the roads, and that really is a shame. It is shifting, and but it's the folks that aren't designing the roads are missing out on a bunch of operational benefits by doing so. So these are, by using a road design software, it puts all the information that a planner can find useful to figure out where that road should go right in front of them. It makes it easy to explore different options and consider things like geometry, drainage, how much earthworks is required to build it. Look at interference areas so you can make a 3D model of your road and see how that's going to interact with the surrounding area. And it also makes it easier to follow design standards. So these are kind of some superficial benefits, but those superficial benefits have some more significant overarching benefits for your operation. So those benefits lead to reducing your uncertainty in your plan, reducing indecisiveness in your planners, so improving or reducing planning time by reducing indecisiveness. Also making sure that the actual best solution is the one that's pursued, and reducing indecisiveness amongst your builders, so they have a plan in front of them when they're building the road. They know what it should look like when it's done. Other big benefits: improve your road's safety and reliability. So referring back to incorporating design standards, from a safety standpoint, you can use design standards to improve things like curve design. So if you have a corner in your road, specify the specs for the corner so it matches your design speed and people aren't traveling down the road elsewhere at 80 kilometers an hour and think they can take the turn and go off the road because of it. And then building upon that as well, also the reliability standpoint. So even if it's not necessarily for the safety of the road's geometry, you can incorporate or add more consideration into how you can improve the road's reliability. Maybe it's not necessarily even a new road, but you're upgrading an existing road from a seasonal road to an all-season road, and you can incorporate your road prism design in that and get something that'll work and have a good idea what that's going to cost you, and how much effort's required to build it. So that how much it's going to cost you, how much effort's required to build it, leads us into estimating. So it's super useful to improve your estimating, so cost estimates, scheduling, etc. And then lastly, and maybe most obviously, is the improved communication of having a design to be able to talk to your builders and show them what the expectations are for the finished product, and using that design as documentation. So if anything goes wrong during construction, you can go back to that design and say, well, you didn't do this, this, and this, how come? And use that to figure out a solution going forward. So our software works by basically we're comparing two surfaces. So the first surface is going to be our topo surface, the second surface is going to be our roadway. So we can use a variety of different data types. We can use total station data, hand traverse data, really anything else. This example that I have in front of us is point cloud data from a LiDAR. So for this, we have all the points in there. That includes everything, vegetation, etc. We're going to strip all those vegetation points, building points, etc. out of there, so we're left with just the bare earth points. And we're going to take those bare earth points or ground points and turn them into a tin, and that tin into our digital surface to look at for topography. Now the other surface that we have is our roadway. So if you're using mapping software right now to plan your roads, there's a good chance that you're not really considering the roadway as a 3D object with cross-section geometry. You might be considering it as just a line, but if that's the case, you're missing out on a lot of information. So here we've got our road alignment, so the red line showing up here, that's our road center line that was specified by the designer, and then we've got the cross-section geometry, and that's the black lines going across. And we use that information to construct a surface. Now how those two surfaces interact is what the planners find useful. So here we can see we've got a cut, some fill, so we can, before ever putting equipment on site, we can adjust the alignment. So this cut balances that fill volume so you're not hauling material into site. You can also look at things like crossing geometry. So here I could drop a pipe in the design in a matter of seconds, figure out exactly how long that pipe needs to be to daylight from its inlet to the outlet, the fill slope, and adjust skew, etc. So really improving the plan and having an idea of what's going to happen before you ever put a person on site. The other thing here is we've got some curvature, a vertical curve and a horizontal curve, and those curves follow the design standard. So this road is going to be safe. So how does it all work? That 3D view stuff, you can use that when you're designing if you'd like to. Most folks that use the software predominantly rely on these three windows. So we've got our cross-section geometry where we define our the geometry of a road cross-section. That it's very straightforward to set it up. We've got a cross-section template, and it's basically a fillable form where you can adjust the dimensions and capture whatever you really want there for roadway geometry. There's some smarts built in, so it'll figure out what fill slopes to use based on material at the site, and what cut slopes to use, etc. And it's going to extend those down to the ground. You can include things like stripping and whatnot. So that's cross-section geometry. Then we have the alignment. So the alignment is a 3D alignment, but it's usually best to consider it as two separate views. So our plan view being the horizontal alignment, and the profile view being the vertical alignment. So we can adjust all these, and since it's a 3D software, if I move my plan view around, my cross-section is going to update to show the appropriate ground underneath it, and the profile is going to update as well. So, and vice versa. As you move it around, everything updates in real time, and it'll also track things like volumes and material movements for you. So having all that in front of you and making it easy to adjust ultimately lets your planners make better decisions. They can explore different options. They can really easily see, okay, I should put this here because if I put it over there, that's going to move more volume. It's going to interfere with that creek. We're going to need another cross drain, etc. And then we can look at the details of that to reduce uncertainty. So for that crossing example where we had that big fill, the planner or designer can plop a digital culvert in there and say, okay, that culvert should be this long. And now when you go to order your culverts, for example, you can avoid under or overestimating material requirements. You can order what's required so you don't end up with either an excessive contingency in ordering too much materials, or even worse, not ordering enough materials and slowing down production and operations. And then the last point we have here is reducing indecisiveness. So putting all that information in front of the person is useful just so they don't end up humming and hawing and exploring different options without ever really knowing for certain which way they should go, and they're bouncing back and forth, etc. It also reduces indecisiveness of your builder. So if you give them a design, so formatted drawing, they know exactly what the expectations are for that road to look like when they build it. All right, so part of the making better decisions and reducing indecisiveness and improving certainty, or reducing uncertainty, is it stems from the improvements in estimating. So oftentimes, without using any kind of design software, road construction is viewed as being a qualitative process. So things are either difficult, normal, easy, etc. That is problematic in a lot of cases. So if you're communicating with other planners and you say it's going to be easy to build a road through here and their easy is different than your easy, schedules get mixed up. So the software lets you move away from that and use a much more quantifiable approach. So the drivers for road construction costs are going to be how much material is being handled and how far is it being moved. From that, if you build on that, and if you come up with some unit rates, so you can use in-house data for developing your unit rates, or based on tabulated cycle times and equipment rental rates, you can really nail down things like cost estimates, scheduling, figuring out construction duration, and also setting production targets for your builders to shoot for. Now, cost estimates can be fairly tedious if you're doing them by hand, and the practicality of exploring every option with a full cost estimate as you move around and adjust your alignments isn't that practical. So to get away from that, we've built it into the software so we can, or the user can define their handling costs, so how much it's going to cost to excavate given material, how much it's going to, per unit volume, how much it's going to cost to place that material, and how much it's going to cost to move that material. From there, the software will continually update your expected costs and put that information right in front of the planner so they can make better decisions. Now, kind of a cool thing of the software, or a newer feature, and I find it really interesting, but I won't go into too much of the details here, is the optimization side of the software. So now that we have the road construction process defined in quantifiable terms, and we've defined the relationship for what drives the costs, the fine folks at Softree have created optimization side to their software. So this is going to take or it has taken the road design process and turned it into a semi-automated one. So the user can define their design constraints, so say define curvature requirements for design speed, requires locations where you need say overlanding, so minimum fill depth. You can define all those things and then click a few buttons and the computer is going to adjust the alignment to minimize construction costs while adhering to those constraints. Yeah, so it's a pretty significant advancement in the technology side of road design, and it's very cool. So we've covered kind of the engineering technical side of things, but having a excellent plan but not being able to communicate that plan to those that have to implement it is it's useless. So to get around that, we have some great output options. For digital exports, we cover things like exporting land XML. So if you're doing detailed construction staking with survey equipment, or if you have GPS machine controlled equipment, you can give them a land XML file and build your road right from that. Other formats that are common are shape files. So, we can export those, and not on the list there, but Venza as well. So if you want to produce a georeference design, you can, and you can use that with the GPS. Now, for a more traditional approach, we have these pre-formatted workbooks that you can set up, you can customize, you can really make them show whatever you want, whether it's cross-section view, plan view, profile view, data tables, etc. You can tweak the format to those so it looks exactly the way you want it, and you can share that amongst multiple designs. So as you're designing, you get to the point where you're content with the technical side of things, and then it's time to plot the design. With a few clicks, you can populate one of these pre-formatted workbooks and have a finished product ready to send to your builders. So in summary, first, thank you for your time for watching our presentation. I think our software has the potential to really help your operations. So if you're building roads or upgrading roads, I think we're a great choice. And using a software is going to offer you benefits such as geometry improvements, reducing your costs, improving your documentation, and improving the confidence you have in your plan. A full design with RoadEng is very quick and easy. We do pride ourselves on that and touting ourselves as the easiest engineering software you'll use, and I really believe that. And lastly, you can make the road design process as simple or as complex as you want. It's really up to you for how detailed you make these things. Yeah, if you have any questions, feel free to reach out to us. You can also check out our website, and we'd be more than happy to help you out. Thank you.